Lucy. Lucy, I'm going crazy. I need your help in calculus.
Oh, I'll be more than glad to help you. What is it that you need help with?
Integration by parts. It's very confusing, I'm completely lost.
Oh, well, okay. I'll start at the beginning and give you a mini lesson on this topic. Are you ready?
Yes. I've never in my life been more enthusiastic to learn. You may start.
Sit. I'll use my math teacher, Miss Merkel's notes to help you fully understand this section.
Okie dokie.
Integration by parts is a technique of finding antiderivatives of more complex functions. The formula for this theorem arises from undoing the process of differentiating, which uses the product rule. So we will begin with differentiating f of x times g of x, and we get first times the derivative of the second, plus second times the derivative of the first. This shows that f of x times g of x is an antiderivative of this whole piece. Now we integrate both sides to get f of x times g of x equals integral of f of x times g prime dx plus integral of g of x times f prime dx. So now by rearranging this, we can solve for integral of f of x times g prime, and we get f of x times g of x minus integral of f prime times g of x dx. To make this simple, let's assign u as f of x, v as g of x, du as f prime dx, and dv as g prime dx. Hence we get integral of u dv equals uv minus integral of v du. This isn't too hard to remember now, is it?
Nope. It's as easy as adding 2 and 2. Ha 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 ha.
Okay. Now we will work at some examples. But before that, I'll clarify to you the 3 main steps required in doing them. First, you strategically pick u and dv. Then, you find du, by taking the derivative of u, and find the v, by integrating dv. And lastly, you simply apply the formula. Let's evaluate the integral of x times cosine of x dx. Let u equal x and dv equal cosine of x dx. By deriving u, we get dx. And by integrating dv, we get v equals sine of x. N. This gives us x sine of x minus integral of sine of x dx. To further simplify this, we will find the integral of sine of x, which is cosine of x. We now have our final answer, x sine of x plus cosine of x plus c, since it is indefinite. Now, let's look at this problem. We have to find the definite integral of t times e to the 2t dt, from 0 to 1. As the first step says, we have to first assign a u and a dv. So, we will make u equal to t, and dv equal to e to the 2t dt. After, we derive u, getting dt, and integrate dv, which requires us to do a u substitution. Thus, we make 2t equal u, and by deriving it, we get du equals 2 dt. So by dividing it by 2, we now have half du equals dt. Now we can say that v equals half e to the 2t plus c. By plugging this info in the formula, we get half t e to the 2t from 0 to 1 minus integral of half e to the 2t dt from the same interval of 0 to 1. Then, we just copy the first part and integrate the second half, getting half t e to the 2t minus half times half e to the 2t from 0 to 1. Then we just multiply half and plug in our bounds. This gives us our final answer, which is 1/4 e to the 2 plus a fourth. Tired yet? We will now work on integrating another indefinite integral of x squared times sine of x dx, making u equal to x squared and dv equal to sine of x dx. We get du equals 2x dx and v equals negative cosine x plus c. Then, applying the formula, we get negative x squared cosine x minus integral of negative cosine x times 2x dx. Now how do we find the integral of the second half? You may realize, or should I say, you should realize, that this requires that we apply the integration by parts formula again. Hence now again, we assign u as 2x and dv as cosine of x dx. By deriving u, we get 2 dx, and by integrating dv, we get v equals sine of x plus. Now by plugging the info in the formula, we get 2x sine x minus integral of 2 sine x dx, not du, sorry. Now we just copy down the previous first part and then the latter first part, and we subtract the integral of 2 sine x dx, not du, which is 2 cosine x, and then add the remaining c. This is our final answer. Negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. Let's now work at a shorter example. What is the indefinite integral of ln of x dx? First, we make u stand for ln of x, and dv stand for dx. Deriving u, we get 1/x dx, and integrating the dv, we get v equals x. Now we can substitute this back in our original integration by parts formula, getting x times ln of x minus integral of x times 1/x dx. So this becomes 1 dx. Then we rewrite the first part and integrate the second, which yields x. Hence, our final answer is x times ln of x minus x plus c. Now we will look at a little challenging problem. What is the integral of e to the x times sine of x dx? So we begin by making u sine of x and dv e to the x dx. Deriving u, we get du equals cosine of x dx, and by integrating dv, we get v equals e to the x. Now we plug in our formula, getting integral of e to the x times sine of x dx equals e to x sine of x minus integral of e to the x cosine of x dx. Now in order to integrate the second part, we have to reuse the integration by parts formula, using u equals cosine of x and dv equals e to the x dx. Now we have du equals negative sine of x. Add the dx, and v equals e to the x. Plugging this into the formula, we get e to the x cosine of x plus integral of e to the x sine of x dx. Since there's a minus sign, we subtract this whole piece. Now I'll just rewrite what we have so far. Then, after realizing that we have two same terms on both sides of our equation, we just bring one to the other side, hence cancelling it out on the right. So now we have two integrals of e to the x sine of x dx equal to e to the x sine of x minus e to the x cosine of x. Now we can just divide by 2, resulting in our final answer, which is half times e to the x sine of x minus e to the x cosine of x plus c.
Oh, I totally get it now. It wasn't as hard as I thought. Thank you so much for helping.
No problem. And I'm sure you'll get a 100 now on your integration by parts test.